we kind of want to find the horizontal asymptotes, right? And in order to find the horizontal asymptote, that's actually the same thing as the end behavior. So basically, it's what happens as x approaches infinity, what happens to our y values, and as x approaches negative infinity, what happens to our y values. Well, if we look over here, as x approaches infinity, as we go to the right, okay, so as we go to the right, well, as we go to the, oops, sorry, I kind of lost track of where the mouse passed, but as we go to the right, well, what's happening to my y values? Well, if you look here, my y values are approaching. You can kind of see as I'm going to the right, maybe I'll just stay here, as I'm going to the right, it's getting closer and closer to what y value? What y value? Well, the y value seems to be 1, all right? So as x approaches infinity, my y value is 1. Now let's look over here. Well, as x approaches negative infinity, what's happening to my y values? It's going down, right? We'll keep going like that, and you can see that it's getting closer and closer to 1 as well, all right? And you can see our end behavior is letting us know essentially then that we have a horizontal asymptote. We have a horizontal asymptote at y is equal to 1. Okay, and you can see that right here. Right, I'll go ahead and draw it in. You could see this is what my function, oops, seems to be approaching right there. That's the horizontal. It's a horizontal, right? Different from vertical asymptotes, right? This is my vertical asymptote right here. Right there. So the horizontal is right there, and it's the end behaviors. What happens to our y values as x gets really big and x gets really big on the negative side? Well, they're both approaching 1. And how do we make sense of that with the equation? Well, the idea is, well, as x approaches infinity, right, what's happening to my y values? Well, the idea is, what happens if I was to plug in, let's say, I was to plug in 30 billion. Okay, do you think this plus 3 would make a difference? No, it really honestly wouldn't. We put 30 billion into this equation, right? 30 billion plus 3 is not that big of a deal. 30 billion plus 7 is not that big of a deal, right? The plus 7 and plus 3 become insignificant. So when we're looking for horizontal asymptotes, right, we're plugging in such big numbers that these plus 3 and plus 7 become insignificant. So we just focus on the degree, well, the highest number of x's on the numerator and denominator. So this is just the same thing as, well, x divided by x. And well, x divided by x cancels out to just give you 1. This is why our horizontal asymptote is at y equals 1. All right? Well, why don't we go ahead and try to make sense of this with another example here. All right, so let's say we have a function, a very similar function. Let's say we have x squared plus 2 divided by x to the 3 plus 4. Okay, again, we want to find our horizontal asymptote. Okay, well, that's asking what happens, to our y values as x gets really big. And generally, we always ask what happens to the y values as well as x gets really big from the negative side. But if we look here, right, we plug in 30 billion into this equation. This plus 2 becomes irrelevant. We're just going to focus on essentially right here, we're focusing on the highest degree, which is x squared, and we focus on the highest degree variable, which is x to the third. Well, what's going to happen? This is the same thing as x times x divided by x times x times x. These are going to cancel out, and you're just going to get 1 over x. So as we plug in really big numbers on the bottom, for example, let's start off with 1 over 10, right? We're going to get something like 0.1. Right? Now let's say that we try 1 divided by 100. All right, so we knew 1 divided by 10 gave me 0.1. Well, what's 1 divided by 100? Well, that's going to give me 0.01. And if I try to divide by 1,000, so 1 divided by 1,000, I'm going to get 0.001. Well, what's happening to my y values now? Well, you could see that the bottom, right, is getting bigger, so the whole thing is becoming a smaller and smaller number, and it's approaching 0, right? 0.1, 0.01, 0.001. So this is approaching 0. So my horizontal asymptote would be y is equal to 0. Okay? And you're going to see this is always going to happen when the degree of the denominator is larger than the degree of the numerator, because the bottom is going to grow faster and essentially get us closer to 0. All right, so maybe let's look at a different example. Again, same principle, same ideas. All right, let's take maybe this example now. Let's say x to the 5th divided by, x to the 4th plus x to the 3rd plus x squared. Okay. Well, again, if we start to plug in a large amount of numbers, okay, x to the 5th is going to grow way quicker than any of these values down here, right? And so again, we only focus on the highest degree on the numerator and on the denominator. So let's just rewrite this as x to the 5th over x to the 4th. Well, we want to find the horizontal asymptote of this. Well, as x gets really big, what is happening to my y values? Well, it's just going to keep it, the numerator is going to get bigger and bigger and bigger compared to the denominator. Therefore, their y values are going to keep increasing, so it's just going to approach infinity. And this is a scenario where we don't have a horizontal asymptote. All right? Because the numerator is going to grow quicker than the denominator. All right, well, okay, now let's go ahead. So there's 3 different scenarios that can occur, right? Let's say we have 2, we have x squared plus 4 divided by x squared plus x plus 1. Again, this is one scenario. This is another one. Let's say we have x plus 3 times x minus 2, all divided by x plus 4, x plus 5, and x plus 6. And then we have something over here. Let's say that this is x to the 6th, x plus 2. And over here is x to the 3rd, x plus 1. So if we want to find the horizontal asymptote of all 3 of these, well, we just focus on the highest degree variables, right? So here, if we focus on the highest degree variables, well, it's x squared. Again, we plug in really big numbers, the plus 4 becomes insignificant. So we're just going to have 2x squared divided by, right? We can ignore this right here, and this is just x squared. Well, what's going to happen? These are going to cancel out, and so my vertical asymptote is y equals 2. Okay? This is saying as x approaches infinity, that's exactly what's going to happen. These are just going to cancel out. These are insignificant, and we get 2. Let's look at this over here. Well, we're going to have x times x on the numerator, that's x squared, and I'm ignoring everything else because it's insignificant. Here we have x times x, which is x to the 3rd. So as x gets really big, what's going to grow faster? The numerator or denominator? Well, the denominator. So since the denominator is getting bigger and bigger, this is going to get smaller and smaller. Therefore, y is going to equal 0. Right? Because we're just going to keep getting smaller and smaller, and so our horizontal asymptote is y equals 0. Now let's look at this one. Well, we have x to the 6th times x, so that's x to the 7th divided by, well, x to the 3rd times x, so we get x to the 4th. Again, ignoring the plus 2 plus 1, because if I plug in 30 billion, these are insignificant. Now, which one, as x goes to infinity, what's going to get bigger, the top or the bottom? Well, the top is going to get bigger and bigger and bigger. So it's going to keep increasing. So there's no horizontal asymptote. Numerator gets larger. Numerator gets larger than denominator. Okay? Hopefully that helps you to understand horizontal asymptotes. We just